The universe is full of facts that sound almost impossible. A star so large it could swallow millions of suns, a planet where glass may fall from the sky, a black hole so powerful that even light cannot escape, and galaxies so far away that their light began traveling before Earth even looked the way it does today. But these are not science fiction stories. They are real parts of the universe we live in. Tonight, we are going on a calm journey through some of the most fascinating facts about space, time, planets, stars, black holes, galaxies, and the strange physics that shapes everything around us. Some of these facts will make the universe feel beautiful. Some will make it feel terrifying. And some may change the way you look at the night sky forever. Before we begin, tell me in the comments, what country are you watching from? And what time is it there right now? Welcome to Falling into Space. And if you enjoy calm space documentaries and strange facts about the universe, don't forget to subscribe. Because for the next hour, we are going to explore the universe through facts that are almost too strange to believe. Before we talk about black holes, strange planets, dark energy, or the edge of the observable universe, we have to begin with something much closer, right here, with Earth. Because one of the strangest facts about the universe is that you are never truly still, even if you are lying in bed, completely quiet, listening in the dark. Your body is moving at incredible speed. The Earth is rotating beneath you. At the equator, the surface moves at more than 1,600 kilometers per hour. You do not feel it because everything around you is moving with it. The air, the oceans, the ground, the buildings, your room, your body, all of it is turning together. But that is only the first motion. Earth is also orbiting the Sun at around 107,000 kilometers per hour. Every second, our planet travels almost 30 kilometers through space, following a curved path around the star that gives us light and warmth. And even that is not the full story. The Sun itself is moving around the center of the Milky Way. Our entire solar system is traveling through the galaxy at hundreds of thousands of kilometers per hour. The planets, moons, asteroids, comets, and everything connected to the Sun are being carried along on this enormous galactic journey. And the Milky Way is moving too. Our galaxy is not fixed in space. It is moving through the local universe, pulled by gravity, shaped by nearby galaxies, and slowly heading toward Andromeda, the closest large spiral galaxy to us. So even in your stillest moment, you are moving in several ways at once. You are rotating with Earth, orbiting the Sun, traveling through the Milky Way, and drifting with our galaxy through the universe. This is one of the first quiet facts that changes how you see reality. Stillness is an illusion. Everything is in motion, but because the scale is so large and because the motion is so smooth, we experience it as calm. The universe is moving beneath us like a silent river, and we are carried with it every second of our lives. Now, look at the Sun. From Earth, it feels familiar. It rises, it sets, it warms the day. It seems close, almost ordinary, because we see it so often. But the sun is not ordinary. It is a star, a giant sphere of plasma, more than 100 times wider than Earth, containing more than 99% of all the mass in the solar system. That means almost everything in our solar system is the sun. The planets feel important to us because we live on one of them. But compared to the sun, they are tiny. If Earth were placed next to the sun, it would look like a small dot. More than 1 million Earths could fit inside the volume of the sun. And yet, the sun is not even close to being one of the largest stars in the universe. It is medium-sized, stable, ordinary in many ways. There are stars far larger, far brighter, far hotter, and far more violent. Some stars are so large that if you place them where the sun is, their outer layers could stretch beyond the orbit of Mars, or even farther. These stars are not just bigger versions of the sun. They are cosmic giants, burning through their fuel quickly, living shorter, more intense lives, and ending in some of the most powerful events in the universe. But the sun is different. It is steady, and that steadiness is one reason we are here. The sun has been shining for billions of years. It is powered by nuclear fusion in its core, where hydrogen atoms are forced together under extreme pressure and temperature, creating helium and releasing energy. That energy begins deep inside the sun, but it does not escape immediately. A photon created in the sun's core can take an incredibly long time to work its way outward, bouncing, being absorbed, re-emitted, and redirected again and again through the dense solar interior. But once that energy reaches the surface and escapes into space, it travels to Earth in about 8 minutes. That means the sunlight touching your face is already 8 minutes old. You never see the sun exactly as it is right now. You see it as it was 8 minutes ago. And this is true for everything in space. Light takes time to travel. The moon is about 1 light second away. The sun is about 8 light minutes away. Neptune is several light hours away. The nearest star system is more than 4 light years away. When you look at the stars, you are looking into the past. A star 10 light years away is seen as it was 10 years ago. A galaxy 1 million light years away is seen as it was 1 million years ago. A galaxy billions of light years away is not being seen as it is today, but as it was when its light began traveling across the universe. This means the night sky is not a live image. It is a time machine. Every point of light is a message from another moment. The universe does not show us everything at once. It sends us layers of history, arriving at the speed of light. And the deeper we look, the older the universe becomes. This is why telescopes are so powerful. They do not only see farther, they see earlier. When powerful telescopes look into deep space, they capture light from galaxies that existed billions of years ago. Some of those galaxies are so distant that their light began traveling when the universe was much younger than it is today. We are not just seeing where things are, we are seeing what they used to be. The universe is a giant archive, written in light, and Earth is receiving old pages from that archive every second. Now think about the Milky Way. On a dark night, away from city lights, you may see a pale band stretching across the sky. That glow is not a cloud. It is not mist. It is the combined light of countless stars inside our own galaxy. The Milky Way is a vast spiral galaxy, home to hundreds of billions of stars. Our Sun is only one of them, not at the center, not in a special position, just one star in one spiral arm, orbiting around the galactic center. And at the center of the Milky Way, there is a supermassive black hole called Sagittarius A star. It has millions of times the mass of the Sun, packed into a region so dense that nothing, not even light, can escape once it crosses the event horizon. But from where we are, it is far away, around 26,000 light-years from Earth. The Milky Way is so large that even light needs tens of thousands of years to cross major parts of it. If you could travel at the speed of light, which no spacecraft with mass can do, it would still take around 100,000 years to cross the galaxy from side to side. And our galaxy is only one galaxy. This is where scale begins to become almost impossible. For a long time, humans did not know there were other galaxies. The Milky Way felt like the universe itself. Then we discovered that some faint smudges in the sky were not clouds inside our galaxy, but entire galaxies outside it. Huge systems of stars, each one possibly containing billions or even trillions of stars. The Andromeda Galaxy, our large neighbor, is about 2.5 million light-years away. That means the light we see from Andromeda tonight began traveling toward us before modern humans existed. When you look at Andromeda, you are seeing ancient light, a signal from before human history, before cities, before language as we know it, before everything familiar in our world. And Andromeda is considered nearby on cosmic scales. Beyond it are countless other galaxies, some close enough to study in detail, others so distant that their light has been stretched by the expansion of the universe. In deep field images, a tiny patch of sky can contain thousands of galaxies. Not stars, galaxies, each one with its own stars, planets, black holes, nebulae, and history. This is one of the most overwhelming facts in astronomy. A piece of sky that looks empty to the human eye may be filled with galaxies when seen through a powerful telescope. The darkness above us is not empty. It is crowded with distance. Now think about the number of stars. In the Milky Way alone, there may be hundreds of billions. Across the observable universe, there may be more stars than grains of sand on Earth's beaches. And around many of those stars, there may be planets. We used to wonder if planets were rare. Now we know they are common. Thousands of exoplanets have been confirmed, and many more are likely waiting to be discovered. Some are gas giants, larger than Jupiter. Some are rocky worlds. Some orbit extremely close to their stars. Some orbit in systems with multiple suns. Some may be frozen. Some may be scorched. Some may have atmospheres. Some may have oceans. The universe is not just full of stars. It is full of worlds, and most of them are completely unknown to us. Imagine that. Billions of planets in our galaxy alone, many of them never seen directly, never visited, never touched by sunlight from our sun. Worlds with alien skies, alien storms, alien nights. Some may be lifeless rocks, some may be gas worlds without surfaces, some may be covered in ice, some may be so hot that metals could melt, and somewhere, perhaps, there may be worlds with conditions that allow life. We do not know how common life is. That remains one of the greatest questions in science. But we do know the ingredients for planets are everywhere. Stars form from clouds of gas and dust around young stars. Leftover material can gather into disks. Inside those disks, grains collide, stick together, grow into rocks, then planetesimals, then planets. The same universe that creates stars also creates worlds around them. This means Earth is not floating in an empty universe. It is part of a cosmic pattern. Stars create elements. Elements form planets. Planets can create environments. And in at least one place, those environments produced life capable of looking back at the stars. That is us. We are not separate from the universe. We are made from it. The atoms in your body were not created on Earth. Hydrogen was born in the early universe. Heavier elements like carbon, oxygen, nitrogen, iron, and calcium were forged inside stars or in violent cosmic events. The iron in your blood, the calcium in your bones, the oxygen you breathe, the carbon in every living cell, all of it has a cosmic history. You are made of ancient material. Parts of you were formed inside stars that lived and died before the sun was born. This is not poetry. It is physics. Stars are element factories. When massive stars die, they scatter heavy elements into space. Those elements mix into new clouds. New stars form. Planets form around them. And sometimes, on those planets, chemistry becomes biology. So when you look at the universe, you are not looking at something completely outside yourself. You are looking at your origin. The universe is not just where we live, it is what we are made of. And maybe that is the most beautiful fact of all. The same cosmos that feels cold, dark, and impossibly vast also created the atoms that make thought possible. It created the stars, the planets, the chemistry, the time, and eventually the eyes that could look up and wonder. So, when we begin a journey through the most interesting facts about the universe, we should start with this. You are moving through space right now. You are orbiting a star. That star is one among hundreds of billions in the Milky Way. The Milky Way is one among billions of galaxies. Those galaxies are filled with stars, planets, black holes, dust, and light. And the atoms inside your body were made by the same cosmic processes that shaped everything above you. The universe is not distant. It is not just something out there. It is beneath your feet, inside your lungs, in your blood, in your bones, in every breath you take. You are a small part of it, but you are also a way for it to know itself. And tonight, as we continue deeper, that is the thought to hold on to. The universe is enormous beyond imagination, but somehow, from one tiny planet, we are able to understand pieces of it. And every fact we learn makes the darkness above us feel a little less empty. and a little more alive. One of the strangest facts about the universe is that gravity does not only pull on objects, it also bends time. This sounds impossible at first because time feels invisible. You cannot touch it. You cannot see it passing. But in the universe, time is not separate from space. They are connected into something called space-time, and massive objects bend it. The stronger the gravity, the more time changes. Here on Earth, the effect is tiny. Time passes almost the same for everyone in daily life. But if you could stand near something extremely massive, like a black hole, time would begin to behave differently. From your point of view, your clock would feel normal. Your heartbeat would feel normal. Your thoughts would feel normal. But someone far away, watching from a safer distance, would see your time slowing down. You would appear to move more slowly. Your signals would stretch. Your light would shift. The closer you move to the black hole, the more extreme the effect would become. This is not science fiction. It is part of how gravity works. A black hole is not just an object with strong gravity. It is a place where gravity becomes so intense that space-time curves inward, beyond return. There is a boundary around it, called the event horizon. Once something crosses that boundary, it cannot escape. Not a spacecraft, not even light. And because light cannot escape, the inside of a black hole is hidden from the outside universe. That makes black holes some of the most mysterious objects in existence. We can study what happens around them. We can see matter heating up before it falls in. We can detect the motion of nearby stars. We can observe jets of energy launched from regions near some black holes. We can even detect gravitational waves when black holes collide. But what happens beyond the event horizon remains one of the deepest mysteries in physics. The universe gives us clues from the outside, but the inside stays silent. Now imagine falling toward a black hole. At first, it might look like a dark circle surrounded by distorted light. The stars behind it would bend around it because the black hole's gravity warps the path of light itself. The view would become strange. Space would appear stretched. Light would form rings. The universe behind you might look compressed and twisted. And as you got closer, the difference in gravity between your head and your feet would become stronger. This stretching force is called tidal gravity. Near a small black hole, it could tear objects apart before they even reached the event horizon. Near a supermassive black hole, the horizon could be so large that you might cross it without noticing the exact moment. But even then, there would be no escape. Once inside, every possible path leads deeper. Not because you are being dragged through space like falling into a hole on Earth, but because space-time itself is curved so strongly that the future points inward. That is one of the most unsettling facts about black holes. Inside the event horizon, escaping is not just difficult. It is not a direction the future allows. Now think about the opposite extreme, a neutron star. If a black hole is what happens when collapse goes too far, a neutron star is what remains when a massive star collapses into an object almost unbelievably dense, but not quite, into a black hole. A neutron star can contain more mass than the sun packed into a sphere only about the size of a city. That means its matter is crushed to a level far beyond anything on Earth. A teaspoon of neutron star material would have a mass of billions of tons, not because it is magical, because the atoms have been crushed so violently that normal atomic structure breaks down. Electrons and protons are forced together, forming neutrons, creating an object made mostly of ultra-dense nuclear matter. The gravity on the surface would be terrifying. If you could somehow stand there, which you could not, the pull would be so extreme that your body would be flattened instantly. The surface is not like ordinary rock. It is more like a crust of exotic matter, under pressures beyond imagination. Some neutron stars spin incredibly fast. When they emit beams of radiation from their magnetic poles, and those beams sweep past Earth like lighthouse beams, we call them pulsars. Some pulsars spin many times per second. Their pulses can be so regular that they become cosmic clocks. Imagine that, a dead star crushed into a city-sized object, spinning with such precision that astronomers can use its rhythm to study physics across the galaxy. But neutron stars can become even stranger. Some have magnetic fields so powerful that they are called magnetars. A magnetar's magnetic field is far stronger than anything humans can create. If one came too close, its magnetic field could disrupt matter itself at enormous distances. These objects can release powerful bursts of energy, sometimes in sudden flares that briefly outshine many ordinary stars. And yet, they are small compared to most cosmic objects. This is one of the universe's strangest patterns. Some of the most powerful things are not the largest. A neutron star is tiny compared to a normal star. A black hole can be invisible. A magnetar could fit inside a city-sized region. But their density, gravity, and magnetic fields make them extreme beyond ordinary imagination. Size alone does not define power in the universe. Density does. Gravity does. Now move from dead stars to planets, because planets can be stranger than anything science fiction ever imagined. There are planets that orbit so close to their stars that a year lasts only a few Earth days. There are planets where one side may be permanently facing the star, while the other side is trapped in endless darkness. This happens when a planet is tidally locked. One hemisphere is always day, the other is always night. Between them may be a narrow twilight zone, a permanent boundary between burning light and frozen dark. On some worlds, winds may race from one side to the other, carrying heat across the planet in violent atmospheric streams. Other planets are so hot that metals could exist as vapor in the air. Some worlds may have clouds made of materials that would seem impossible from Earth's point of view. There are gas giants orbiting extremely close to their stars, heated to enormous temperatures. Their atmospheres can be blasted away by radiation, creating trails of escaping gas. There are planets with extreme pressure, where atmospheres are thick, heavy, and violent. There may be ocean worlds, with water covering the entire surface, no continents at all, just endless sea under alien skies. There may be frozen worlds with oceans hidden beneath ice shells, kept warm by internal heat or tidal forces. And some of the most interesting places for life may not be planets like Earth at all. They may be moons. A moon orbiting a giant planet could be warmed by gravitational squeezing. As it moves through its orbit, the pull from its parent planet and nearby moons can flex its interior, generating heat. That heat could keep a hidden ocean liquid beneath ice. And if there is water, chemistry, and energy, then maybe there is a possibility of life. Not life on the surface, under sunlight, but life in darkness, deep under ice, around chemical vents, living in a way completely different from plants and animals on Earth. This reminds us that habitability may be more creative than we once thought. For a long time, humans imagined life needing a world like Earth. Blue sky, warm sunlight, land and oceans. But the universe may allow life in places that look completely hostile from the outside. A frozen moon may hide an ocean. A dark sea may have chemistry. A planet far from a star may still have internal heat. Life, if it exists elsewhere, may not follow the picture we expect. It may be hidden, quiet, underground, under ice, or in environments we have not imagined yet. Now think about light again, but in a different way. The light we see is only a small part of what exists. Human eyes detect visible light, a narrow band of the electromagnetic spectrum. But the universe shines in many kinds of light. Radio waves, infrared, ultraviolet, X-rays, gamma rays. Each one reveals a different universe. If you look only with human eyes, space may seem dark and empty, but radio telescopes reveal cold gas, magnetic fields, and distant signals. Infrared telescopes can see through dust and detect heat from stars and planets. X-ray telescopes reveal violent regions around black holes, neutron stars, and hot gas in galaxy clusters. Gamma-ray telescopes detect some of the most energetic events in the universe. This means the universe changes depending on how you look at it. There is no single sky. There are many skies layered together. The visible sky is only one version. A radio sky, an X-ray sky, a gamma-ray sky. Each tells a different part of the story. And without these invisible forms of light, much of the universe would remain hidden from us. The human eye is beautiful, but it is limited. Telescopes extend our senses. They allow us to see the universe in ways our bodies were never built to see. That is one reason modern astronomy feels almost magical. It does not only make distant things closer, it reveals things that were invisible. Now consider the coldest places in space. Space is often described as freezing, but temperature in space is more complicated than it seems. In empty space, there is not much matter to carry heat away through contact. An object loses heat mainly by radiation, but far from stars, shielded from sunlight, objects can become extremely cold. Some regions of the universe are only a few degrees above absolute zero. Absolute zero is the lowest possible temperature, where particles have the minimum possible thermal motion allowed by physics. The universe is cold because it has expanded and cooled over billions of years. The cosmic microwave background The leftover glow from the early universe now fills space at just a few degrees above absolute zero. That faint radiation is everywhere, a whisper from the early cosmos. It is one of the strongest pieces of evidence that the universe was once much hotter and denser. But today, it is cold, very cold. The universe began in heat and light, and over time, as space expanded, that ancient light stretched and cooled into a faint background. This is one of the most poetic facts in cosmology. The entire universe still carries the afterglow of its beginning, not as fire, not as visible brightness, but as a cold, quiet radiation filling all of space. Now think about empty space itself. It is not truly empty. Even in the deepest voids, there are particles, fields, radiation, and quantum activity. The vacuum is not simple nothingness. In quantum physics, empty space can have fluctuations. Particles and fields behave in ways that are deeply strange, and the idea of absolute emptiness becomes difficult to define. On cosmic scales, there are vast regions called voids. These are enormous spaces between galaxy filaments, containing far fewer galaxies than average. A cosmic void can be hundreds of millions of light years across. Imagine traveling through one. There would be no bright neighboring galaxies nearby, only darkness. The nearest large structures might be unimaginably far away. And yet, even voids are part of the structure of the universe. They are not mistakes. They are part of the cosmic web. Matter gathers into filaments and clusters, leaving great empty regions between them. The universe is shaped like foam on the largest scales. Galaxies lie along walls and threads. Clusters sit where filaments meet. Voids open between them like enormous bubbles of darkness. This structure grew from tiny differences in density in the early universe. Small irregularities became larger over time under gravity. Slightly denser regions pulled in more matter. Less dense regions became emptier. Over billions of years, gravity turned tiny ancient patterns into the enormous cosmic web we observe today. That means the largest structures in the universe began as tiny fluctuations. Small differences in the early cosmos became galaxies, clusters, and voids. The universe we see today grew from almost invisible seeds, and inside one of those galaxies, around one ordinary star, on one small planet, life appeared. This is what makes space facts so powerful. They are not isolated pieces of information. They connect. Gravity bends time. Stars collapse into black holes and neutron stars. Planets form in strange environments. Light reveals hidden layers of reality. The universe cools as it expands. The cosmic web grows from ancient fluctuations, and everything, from the largest galaxy cluster to the atoms inside your body, belongs to one continuous story. A story that began long before Earth existed. A story still unfolding now. And the deeper you look, the stranger it becomes. Because the universe is not just full of objects, it is full of rules. Rules that bend time, rules that trap light, rules that crush stars into impossible densities. rules that stretch ancient radiation across billions of years, rules that turn tiny fluctuations into galaxies. And somehow, by studying those rules, we can understand parts of a reality far larger than ourselves. That may be the most astonishing fact of all. The universe is not only mysterious, it is understandable. Not completely, but enough for us to follow its clues, enough to learn that darkness is full of structure, enough to know that dead stars can become cosmic clocks, enough to know that invisible light can reveal hidden worlds, enough to know that the sky is not empty, even when it looks silent. And as we continue, the facts become even stranger, because the universe does not stop at stars, planets, and black holes. It reaches into questions about time, beginnings, endings, hidden matter, invisible energy, and realities so far away that their light may never reach us. The more we learn, the more the universe expands in our imagination, and the more we realize that every answer opens another door. Some of the most important things in the universe cannot be seen directly. That may sound strange, because astronomy feels like the science of looking. We point telescopes into space. We collect light. We study stars, galaxies, planets, nebulae, and distant explosions. But the deeper we look, the more we discover that light is only part of the story. There is something holding galaxies together that we cannot see, something shaping the largest structures in the universe, something pulling on stars, bending light, and guiding the growth of cosmic structure. We call it dark matter. And the name is honest. It is matter because it has gravity. It is dark because it does not shine, reflect, or absorb light in the normal way. We do not see dark matter directly. We see what it does. When astronomers study galaxies, they find that the stars in the outer regions move faster than expected. If only the visible stars and gas were present, those galaxies should not hold together the way they do. The outer stars should drift away, but they do not. Something invisible adds gravity. Something surrounds galaxies like a vast hidden halo. That hidden mass helps keep them stable. And this is not a small detail. Most of the matter in the universe appears to be dark. The stars, planets, gas clouds, dust, and everything made from normal atoms are only a small fraction of what is really there. The visible universe is not the full mass of the universe. It is the glowing part, the detectable part, the part that interacts with light. But beneath that visible beauty, there is an invisible structure shaping everything. Dark matter does not form stars. It does not make planets. It does not create light. But without it, galaxies might not have formed the way they did. It acts like a hidden skeleton of the cosmos, a gravitational framework that normal matter gathered around. In the early universe, tiny differences in density grew under gravity. Dark matter helped pull matter together, forming the first large structures. Gas collected inside these gravitational regions, cooled, collapsed, and eventually formed stars and galaxies. So when you look at a galaxy, you are not seeing all of it. You are seeing the bright material inside a much larger, invisible mass. The galaxy is only the shining part of a deeper gravitational shape. And dark matter is not the only invisible mystery. There is also dark energy. If dark matter helps pull things together, dark energy seems to push the large-scale universe apart. The universe is expanding, but it is not simply expanding at a steady rate. It is accelerating. Distant galaxies are moving away from us faster over time, not because they are flying through space like rockets, but because space itself is stretching. Scientists do not fully understand what dark energy is. It may be a property of space itself. It may be connected to the vacuum. It may be something even stranger, but its effect is enormous. On small scales, gravity wins. Stars hold planets. Galaxies hold stars. Galaxy groups can remain bound, but across the vast distances between galaxy clusters, dark energy becomes dominant. It shapes the future of the universe. It may decide whether distant galaxies remain visible or fade beyond every possible horizon. And together, dark matter and dark energy tell us something humbling. Most of the universe is not made of the things we understand best. The atoms that make stars, planets, oceans, mountains, and living bodies are only a small part of the cosmic inventory. The universe we see is almost like the surface of a deep ocean. Beautiful, important, real, but not everything. Most of the cosmic story is hidden in gravity, expansion, and forces we are still trying to understand. Now think about galaxies. They look peaceful in photographs, like glowing islands floating silently in darkness. But galaxies are not still. They grow. They collide. They consume smaller galaxies. They change shape over billions of years. The Milky Way itself has likely absorbed smaller galaxies in the past. Streams of stars around it may be the remains of smaller systems pulled apart by gravity. And in the future, the Milky Way will merge with Andromeda. This will not look like two solid objects smashing together, because galaxies are mostly empty space. Stars are separated by enormous distances, so direct star collisions will be rare. But gravity will reshape everything. The galaxies will pull on each other. Their spiral arms will stretch and distort. Gas clouds may collide and trigger waves of new star formation. Over time, the two galaxies will become one larger system. This means the sky of the far future will look completely different. The Milky Way, as we know it, is not permanent. Even galaxies have lifetimes. Even galaxies evolve. Now consider stars. Stars are not all born equal. Some are small and dim, burning slowly for hundreds of billions or even trillions of years. Others are massive and bright, living fast and dying young. The most massive stars burn through their fuel quickly because their cores are under extreme pressure and temperature. They shine with enormous power, but that power comes at a cost. Their lives may last only a few million years. That sounds long by human standards, but in cosmic time, it is almost a flash. When these massive stars die, they can explode as supernovae. A supernova is one of the most powerful events in the universe. For a short time, a single exploding star can shine as brightly as an entire galaxy. But supernovae are not only destructive, they are also creative. They scatter heavy elements into space, elements that later become part of new stars, planets, and living chemistry. The calcium in bones, the iron in blood, the silicon in rocks, the oxygen in water. Many of these elements were forged or spread by ancient stars. A supernova is a death, but it is also a cosmic release. The star gives its material back to space, and from that material, new systems can form. This is one of the most beautiful cycles in the universe. Stars are born from clouds. They shine. They create elements. They die. Then, their remains help build the next generation. The universe recycles itself across billions of years. Now there are even more violent events than ordinary supernovae. When certain massive stars collapse, they may produce gamma-ray bursts. These are powerful flashes of high-energy radiation, some of the brightest explosions known. A gamma-ray burst can release in seconds an amount of energy comparable to what the sun will emit over its entire lifetime. Many happen in galaxies far away, so by the time their radiation reaches us, it is only a signal in our instruments. But if one occurred too close and pointed directly toward Earth, it could be dangerous. The universe is beautiful, but it is not gentle. It contains events so powerful that entire planetary atmospheres could be affected from great distances. Yet these extreme events are also part of how the universe changes. They mark the deaths of stars, the births of black holes, the collisions of compact objects, the release of energy on scales far beyond anything human civilization can produce. Now think about planets again, but not the ones orbiting stars. Some planets may wander through the galaxy alone. They are called rogue planets. They do not orbit any star. They drift through interstellar darkness, either formed alone or thrown out of their original solar systems by gravitational interactions. Imagine a world with no sunrise, no sunset, no day, no year in the usual sense. A planet moving through darkness, lit only by distant stars. Some rogue planets may be frozen, silent, and dead, but others might hold internal heat for a long time. If a rogue planet had a thick atmosphere or an ocean beneath ice, it might remain warm enough underground for interesting chemistry. This does not mean life is likely there, but it shows how creative the universe can be. A planet does not always need to belong to a star to exist. Some worlds may travel alone for billions of years, hidden, dark, almost impossible to detect. The galaxy may be filled with such wandering worlds, moving between the stars like invisible ghosts. Now look closer to home. Our solar system is not just planets. It is full of smaller bodies, asteroids, comets, icy fragments, dust, ancient leftovers from the formation of the sun and planets. Comets are especially interesting because they are like frozen time capsules. They formed from icy material in the early solar system. When they come close to the sun, their ice warms and releases gas and dust, creating glowing tails that can stretch for millions of kilometers. A comet's tail does not trail behind it simply because of motion. It is shaped by sunlight and the solar wind. That means the tail often points away from the sun. Comets may preserve material from the early solar system, giving scientists clues about the ingredients that existed when planets were forming. Some theories suggest comets and asteroids may have delivered water and organic molecules to early Earth. Not life itself necessarily, but ingredients, pieces of chemistry. If true, then impacts from space may have helped prepare Earth for life. This makes the solar system feel less like a clean machine and more like a messy, evolving environment. Worlds collide, materials mix, objects migrate. Planets are shaped by impacts, gravity, heat, and time. Even Earth's history was violent. The moon may have formed after a massive impact between early Earth and a Mars-sized body. That impact would have been catastrophic, but it may have helped create the moon, which later influenced Earth's tides, rotation, and long-term stability. A violent event may have helped shape the world that later became home. The universe often works this way. Chaos becomes structure. Destruction becomes material. Collisions become beginnings. Now consider one more strange fact. The universe is not silent in the way we once thought. Sound, as we know it, cannot travel through empty space because sound needs matter to carry vibrations. But the universe has other kinds of waves: light waves, gravitational waves, plasma waves. When black holes collide, they create ripples in space-time itself. These gravitational waves spread outward across the universe at the speed of light. For billions of years, they travel through space. By the time they reach Earth, they are incredibly faint, but with sensitive detectors, we can measure them. This means we are not only seeing the universe, we are beginning to feel its vibrations, not sound through air, but ripples in the fabric of space-time. A collision between black holes far away can slightly stretch and squeeze space here on Earth by an amount smaller than the width of a proton, and we can detect it. That is astonishing. It opens a new kind of astronomy. For most of history, humans studied the universe through light. Now we can also study it through gravitational waves. This allows us to observe events that might be invisible or difficult to detect with telescopes alone. The universe has more than one language. Light is one, gravity is another, and we are only beginning to learn how to listen. The more facts you learn, the more the universe changes shape in your mind. It is not just a collection of stars. It is an active system. Invisible matter shapes galaxies. Invisible energy accelerates expansion. Stars forge elements. Explosions seed space with material. Planets can be thrown into darkness. Comets preserve ancient chemistry. Gravity sends waves across space-time. And everything is connected by processes that began long before Earth existed. This is what makes space facts so powerful. Each one feels separate. At first, a black hole, a comet, a rogue planet, a supernova, a galaxy merger. But slowly, they begin to form one story. A story of matter changing form, of gravity building structure, of time turning violence into possibility, of invisible forces shaping visible beauty. And somewhere inside that story, Earth appeared. Not outside the universe, but made from the same cosmic history. A planet formed from ancient dust, orbiting a star formed from earlier generations of matter, carrying life made from elements born in stars, looking outward at the same universe that created it. That may be the strangest fact of all. The universe is not just something we observe. It is something we belong to, and every mystery we study above us is connected in some way to the story of how we came to exist here. One of the most surprising things about the universe is that the strangest worlds are not always far away. Sometimes they are right here in our own solar system. We live on Earth, so Earth feels normal to us. Blue sky, liquid oceans, breathable air, rain, clouds, mountains, forests, seasons. Everything here feels familiar because our bodies were shaped by this planet. But if you step away from Earth and look at the other worlds nearby, you begin to realize how unusual our home really is. Take Venus. From Earth, Venus can look beautiful. It shines brightly in the sky, sometimes called the morning star or the evening star. It is close to Earth in size, made of rock, and sometimes described as Earth's twin. But that name is deeply misleading. Venus is not a gentle twin. It is a warning. Its atmosphere is extremely thick, made mostly of carbon dioxide, with clouds of sulfuric acid high above the surface. The pressure on the ground is crushing, and the temperature is hot enough to melt lead. It is hotter than Mercury, even though Mercury is closer to the Sun. That single fact tells you something important. Distance from the Sun is not everything. Atmosphere matters. Venus traps heat so efficiently that its surface became one of the most hostile places in the solar system. It shows how a planet can begin with some similarities to Earth and still become completely different. Then there is Mercury, a tiny rocky world close to the Sun, with almost no atmosphere to protect it. During the day, its surface can become extremely hot. At night, without a thick atmosphere to hold heat, temperatures can drop brutally low. One planet, two extremes, a world scorched by sunlight and frozen by darkness. Mercury also has a strange relationship with the Sun. Its orbit is highly elliptical compared to Earth's, and its rotation is slow. A day on Mercury does not feel like a day on Earth. The motion of the Sun in its sky would look strange, slow, and unfamiliar. The closer you look at planets, the more you realize that normal is not a universal idea. Earth is normal only to us. Now look at Mars. Mars is often imagined as the next place humans might visit. It has valleys, mountains, dust storms, polar ice, and ancient features that suggest water once flowed across its surface. But Mars today is cold, dry, and thin-aired. Its atmosphere is far too thin to breathe and too weak to protect the surface properly. Liquid water cannot remain stable on the surface for long under normal conditions. And yet, Mars carries clues of a different past. Ancient riverbeds, deltas, minerals formed in water, signs that long ago Mars may have had a thicker atmosphere and a warmer environment. This makes Mars feel almost like a fossil planet, a world that remembers a time when it may have been more alive geologically, maybe even more friendly to chemistry. One of the most incredible features on Mars is Olympus Mons, the largest volcano in the solar system. It is so enormous that if you stood near its base, you might not even understand you were standing on a mountain. Its slope is so wide and gradual that the scale would overwhelm the human eye. Mars also has Valles Marineris, a canyon system far larger than the Grand Canyon. It stretches across thousands of kilometers, a scar across the planet's surface. Mars reminds us that even a smaller world can hold landscapes larger than anything we know on Earth. Then move outward to Jupiter. Jupiter is not a solid world like Earth or Mars. It is a gas giant, a massive planet made mostly of hydrogen and helium, with no surface you could stand on in the ordinary sense. If you tried to descend into Jupiter, you would pass through clouds, storms, pressure, and layers of gas that grow denser and hotter the deeper you go. Jupiter is more than a planet. It is almost a failed star, though not truly close enough in mass to become one. It would need much more mass to ignite fusion like the Sun. Still, it is enormous compared to Earth. More than 1,000 Earths could fit inside it by volume. Its gravity shapes the solar system. It influences asteroids. It controls a huge family of moons. It may have helped shape the early architecture of the planets, and its atmosphere is one of the most violent places nearby. The Great Red Spot, a giant storm larger than Earth, has been observed for centuries. Winds inside Jupiter's atmosphere can reach incredible speeds, and its cloud bands move in complex patterns driven by heat, rotation, chemistry, and deep atmospheric motion. Jupiter's storms are not like storms on Earth. They are planetary scale systems, huge, colorful, and long-lived. And around Jupiter, there are moons that feel like worlds of their own. Io is the most volcanically active body in the solar system. It is constantly squeezed by Jupiter's gravity and the gravitational pull of nearby moons. This tidal flexing heats its interior, driving volcanic eruptions across its surface. Io is a moon under gravitational torture, a world of sulfur, lava, and constant change. Europa is different. Its surface is covered in ice, cracked and streaked with dark lines. Beneath that ice, scientists believe there may be a global ocean of liquid water. This makes Europa one of the most fascinating places in the search for life. Not because there is life there that we know of, but because it may have some of the ingredients that life needs: water, chemistry, a hidden ocean beneath an icy shell. The idea that life could exist in darkness, under ice, is powerful because it expands our imagination. Life may not need sunlight directly if it can use chemical energy, like some organisms do near hydrothermal vents on Earth. Europa reminds us that the most important oceans in the solar system may not be visible from space. Then there is Ganymede, the largest moon in the solar system, even bigger than Mercury. It has its own magnetic field, something unusual for a moon, and it may also have hidden layers of liquid water beneath its icy crust. Callisto, another large moon of Jupiter, is heavily cratered, ancient, and quiet. Its surface preserves a long history of impacts. Together, Jupiter's moons show that planets are not the only interesting worlds. Moons can be volcanic, oceanic, ancient, alive with geological possibility. Now move to Saturn. Saturn is famous for its rings, and for good reason. They are one of the most beautiful structures in the solar system. From far away, they look like smooth bands, almost solid, but they are not solid. They are made of countless particles of ice and rock, from tiny grains to larger chunks, all orbiting Saturn in a thin, flat disk. The rings are enormous in width, but incredibly thin compared to their size. They are like a cosmic sheet of glittering debris, shaped by gravity, collisions, and the influence of Saturn's moons. And they may not last forever. Over time, ring material can fall into Saturn or be altered by interactions with the planet's magnetic field and moons. The rings may be temporary on cosmic timescales. That makes them even more beautiful. We are seeing Saturn during an era when its rings are still bright and magnificent. Saturn also has Titan, one of the strangest moons in the solar system. Titan has a thick atmosphere, mostly nitrogen, and lakes and seas on its surface. But they are not lakes of water. They are made of liquid methane and ethane. On Titan, hydrocarbons can fall as rain, carve river channels, gather in lakes, and evaporate into clouds. It has a weather cycle, but not a water cycle like Earth's, a methane cycle. Titan is like a cold mirror of Earth, where familiar processes happen with alien materials. It has dunes, clouds, rain, lakes, a dense orange atmosphere, and beneath its icy crust, there may also be a hidden ocean. Titan is one of the best examples of how the universe can create worlds that feel both familiar and completely alien at the same time. Then there is Enceladus, a small, icy moon of Saturn that surprised scientists when they discovered jets of water vapor and ice particles spraying from cracks near its south pole. These plumes suggest that beneath the icy surface, Enceladus has a subsurface ocean. Even more interesting, material from that ocean is being launched into space, where spacecraft can sample it without landing or drilling through the ice. Enceladus is tiny compared to planets, but it may hold one of the most accessible hidden oceans in the solar system. Again, the lesson repeats. Size does not decide importance. A small moon can hold enormous scientific value. Now, move farther outward to Uranus. Uranus is strange because it rotates on its side. Its axis is tilted so dramatically that the planet seems to roll around the sun rather than spin upright like Earth. This may have happened because of a massive impact early in its history. The result is extreme seasons. For long periods, one pole can face the sun while the other is trapped in darkness. Then, as Uranus moves along its long orbit, the situation changes. A year on Uranus lasts 84 Earth years. So seasons, there are not months long. They last decades. Uranus is also an ice giant, different from gas giants like Jupiter and Saturn. It contains more water, ammonia, and methane ices deep inside. under extreme pressures. Its blue-green color comes partly from methane in its atmosphere, which absorbs red light. Then there is Neptune, farther still, a deep blue world with some of the fastest winds in the solar system. Even though Neptune receives very little sunlight compared to Earth, its atmosphere is active and dynamic. This is surprising. You might expect a distant world to be calm and frozen, but Neptune has storms, winds, and internal heat that help drive its atmosphere. Neptune teaches another quiet lesson. Sunlight is not the only source of planetary activity. A planet can have energy from within. Neptune's largest moon, Triton, is also unusual. It orbits backward compared to Neptune's rotation, which suggests it may have been captured from the Kuiper belt. Triton has icy terrain and geyser-like eruptions of nitrogen gas, a captured world orbiting a distant blue planet, carrying clues from the outer solar system. Now think about Pluto. Pluto was once considered the ninth planet, and now it is classified as a dwarf planet. But that change did not make it less interesting. When spacecraft finally visited Pluto, it revealed a world far more complex than many expected. Pluto has mountains made of water ice, smooth plains of nitrogen ice, a thin atmosphere, possible signs of geological activity, and a heart-shaped region that became one of the most famous features in planetary science. This small, distant world, once imagined as a frozen point of light, turned out to be rich, varied, and surprising. That is a pattern in exploration. Whenever we see a world up close, it becomes more interesting. The moon was not just a grey disk. Mars was not just a red point. Jupiter was not just a bright object. Pluto was not just a dot. Every world becomes more complex when approached. And beyond Pluto lies the Kuiper belt, a vast region of icy bodies, dwarf planets, and ancient leftovers from the formation of the solar system. Even farther may be the Oort cloud, a hypothetical distant sphere of icy objects surrounding the solar system, possibly the source of long-period comets. If the Oort cloud exists as expected, it stretches incredibly far from the Sun, far beyond the planets. The solar system does not end neatly at Neptune. It fades outward. Planets give way to icy bodies. Icy bodies give way to distant comet reservoirs. The Sun's influence weakens gradually. Eventually, you reach the boundary where the solar wind gives way to the interstellar medium. This region is called the heliopause. It is not a wall, it is a transition. The place where the bubble created by the Sun meets the space between stars. The Voyager spacecraft have crossed into this region, becoming humanity's farthest messengers. They are small machines launched decades ago, still traveling outward into the darkness. Each carries a golden record, a message from Earth with sounds, images, music, greetings, and information about our planet. The chance that another civilization will ever find them is extremely small. But that is not the only point. The records are symbols. They say that a small world around a small star once built machines and sent them into the dark with a message. We were here. Now think about how far Voyager has gone. It is far beyond the planets, far beyond the familiar solar system. And yet, compared to the nearest stars, it has barely begun the journey. This is one of the most humbling facts in space. Our farthest spacecraft are already in interstellar space, but the nearest star is still so far away that they will not reach anything like it for tens of thousands of years. The solar system feels enormous, but compared to the distance between stars, it is only a small island. The gaps between stars are almost empty. Not completely empty, but close. There are atoms, dust, cosmic rays, rogue planets, maybe comets far from any sun. But compared to the rich environments around stars, interstellar space is incredibly sparse. A spacecraft traveling between stars would pass through vast darkness for longer than human civilizations have existed. This brings us back to the scale of the galaxy. The Milky Way contains hundreds of billions of stars, but those stars are separated by huge distances. If the Sun were the size of a small ball, the nearest star would be many kilometers away. At the same scale, space is not crowded the way pictures make it feel. Galaxies look bright because they contain many stars, but the distances between those stars are enormous. Even when galaxies collide, stars rarely collide directly. The space between them is too large. Galaxies pass through each other like ghostly structures, while gravity reshapes their paths. Now think about time. The universe does not only have strange distances, it has strange timescales. A human life is measured in decades. A civilization may last centuries or millennia. A planet can remain active for billions of years. A small red dwarf star can burn for trillions of years. A black hole may survive for timescales so enormous that ordinary numbers begin to lose meaning. This means we are living in a very early chapter of the universe in some ways. The universe is about 13.8 billion years old, which sounds ancient. But compared to the possible future lifetimes of red dwarf stars, it is young. Many of the longest-lived stars have barely begun their lives. In the far future, after stars like the Sun are gone, red dwarfs may still shine quietly for trillions of years. If life can exist around such stars, then some future life may arise in a universe much older than ours. But the future universe will also be different. Star formation will eventually slow as gas is used up or locked away. Galaxies will age, bright stars will die, the universe will become dimmer over immense spans of time. This is another humbling fact. The universe changes its character with age. We live in the stelliferous era, the era of stars, a time when stars still form, shine, and fill galaxies with light. But this era will not last forever. One day, the bright star-forming universe will fade into a quieter age of remnants. White dwarfs, neutron stars, black holes, cold planets, dim red stars. The universe will not always look the way it looks now. The night sky is temporary, not in a way that affects us tomorrow, but on cosmic timescales, everything changes. Even stars are temporary. Even galaxies evolve. Even the visible universe has a future that looks different from its present. Now think about Earth again. Earth feels stable because it changes slowly compared to our lives. But Earth is also temporary. The sun is slowly evolving. Over billions of years, it will become brighter. Eventually, it will leave its stable phase and expand into a red giant. The inner solar system will change dramatically. Earth will not remain habitable forever. This is not something to fear in a daily sense. It is far beyond human timescales. But it reminds us that habitability is a phase, a window, a period when conditions are right. Earth has been habitable for a long time, but not forever in the past, and not forever in the future. Life exists inside a cosmic timing. Too early, and the ingredients were not ready. Too late, and the conditions may be gone. This makes our moment feel fragile and rare. Now consider the moon. The moon is slowly moving away from Earth by a few centimeters per year. This happens because of tidal interactions between Earth and the moon. The change is tiny in human life, but over millions and billions of years, it matters. The moon was once closer. Tides were stronger. Earth's day was shorter. The relationship between Earth and Moon has changed over time, and it will continue to change. Even something as familiar as the Moon is not fixed. The solar system is not a frozen clock. It is a system of evolving relationships. Planets migrate slightly. Moons move. Rotations slow. Orbits shift. Impacts happen. Atmospheres escape. Volcanoes reshape surfaces. Ice melts and freezes. Dust falls. Radiation changes chemistry. Everything is changing, even when it appears still. This may be one of the deepest facts about space. The universe is not a collection of static objects. It is a collection of processes. A planet is not just a sphere. It is geology, atmosphere, chemistry, magnetism, history. A star is not just light. It is fusion, pressure, gravity, radiation, evolution. A galaxy is not just stars. It is dark matter, gas, dust, black holes, collisions, star formation, and time. Even empty space is not simply empty. It is fields, expansion, background radiation, and quantum uncertainty. When you understand that, the universe becomes more alive in your imagination. Not alive biologically, but active, moving, transforming, interacting. Every object is part of a process. Every process is part of a larger story. And the story never truly pauses. Now imagine being able to watch the solar system over billions of years in fast motion. Planets would dance around the sun. Moons would drift. Comets would fall inward and swing back out. Asteroids would collide. Mars would lose more atmosphere. Saturn's rings might fade. The sun would brighten. Earth's continents would move and reshape. The moon would slowly recede. The outer planets would continue their long, cold orbits. And eventually, the sun itself would change the entire system. What feels permanent is only slow. The universe teaches that permanence is often an illusion created by short lives. We do not live long enough to see mountains move easily. We do not live long enough to watch stars age. We do not live long enough to see galaxies merge, but they do. Time is one of the universe's greatest forces. Not a force like gravity, but a condition that allows everything to unfold. Give gravity time, and dust becomes stars. Give stars time, and elements form. Give planets time, and surfaces change. Give chemistry time, and sometimes life begins. Give galaxies time, and they merge into new shapes. The universe is patient in a way humans can barely understand. And yet, within our short lives, we can learn the story. That is astonishing. We cannot watch a galaxy merger from beginning to end, but we can observe different galaxies at different stages. We cannot see a star live its whole life, but we can study many stars at different ages. We cannot travel to the outer planets easily, but we can send probes and read the light they return. We cannot hold cosmic time in our hands, but we can reconstruct it. Science lets us compress the universe into understanding, not completely, never completely, but enough to see patterns, enough to know that planets are diverse, that moons can hide oceans, that rings may be temporary, that stars evolve, that galaxies collide. That space between stars is vast. That time changes everything. And maybe the most important lesson from all these facts is this: the universe is not strange only at the edge. It is strange everywhere. The planet next door is a furnace. A nearby moon may hide an ocean. A giant planet has storms larger than Earth. A ringed world wears a temporary crown of ice. A tiny moon sprays ocean material into space. A distant dwarf planet has mountains of water ice. Our farthest spacecraft have crossed into interstellar space and still have barely moved on the scale of stars. Every layer of the universe, from the nearest planets to the deepest galaxies, contains something that challenges intuition. And that is why learning about space never feels finished. Every answer leads to a better question. Every world becomes more interesting when seen closely. Every fact opens a door into another mystery. The universe does not become smaller when we understand it. It becomes larger because understanding reveals how much more there is. And as we continue deeper into these facts, we begin to see that space is not only a place of distance, it is a place of transformation. Worlds are born, changed, frozen, heated, broken, captured, hidden, and reshaped. Stars live and die. Moons move and crack. Planets drift. Signals travel. Machines leave home and cross boundaries no human has ever crossed. And from one small world, we follow the clues. We listen. We measure. We imagine. And slowly, fact by fact, the universe becomes not less mysterious, but more meaningful. One of the most powerful facts about the universe is that everything we see today is temporary. Not temporary in a human sense, not temporary like a cloud passing, or a season changing, or a city growing old. Temporary on the scale of stars, galaxies, black holes, and cosmic time. The universe has a history, but it also has a future, and that future is not frozen. It is not a picture that stays the same forever. Every star, Every planet, every galaxy, every cluster of matter is moving through time toward a different state. The night sky looks eternal because human life is short, but the universe is changing constantly, slowly, silently, on scales too large for us to notice in one lifetime. The stars above us were not always there. Some were born before the sun existed. Some will die long before Earth's distant future. Others are so small and efficient that they may keep shining for trillions of years, long after stars like the sun are gone. This means the universe is not one single era. It has chapters. The early universe was hot, dense, and bright in a way we cannot see directly with ordinary eyes. Matter had not yet formed stars. Atoms themselves could not exist in the earliest moments as they do now. Everything was compressed, energetic, and changing rapidly. Then, the universe expanded and cooled. Atoms formed. Light began to travel freely. Gravity slowly gathered matter into larger structures. The first stars ignited. The first galaxies formed. Heavy elements were created inside stars and spread through space when those stars died. New generations of stars formed from that enriched material. Planets became possible. Rocky worlds became possible. Water, chemistry, and eventually life became possible. This means the universe had to age before it could create a world like Earth. We sometimes imagine the Big Bang as the beginning of everything familiar, but the early universe was not ready for planets or life. It needed time to build the ingredients. The carbon in living cells did not exist in the beginning in the same abundance. The oxygen in water had to be forged. The iron inside planets had to be created by stellar processes. The universe had to make stars before it could make us. That is one of the deepest facts in astronomy. Life is not separate from cosmic history. Life depends on earlier stars. Before Earth could exist, other stars had to live and die. Before biology could begin, physics had to create chemistry. Before oceans could form, the elements had to be scattered into space and gathered again into a new solar system. So, when you look at your own hands, you are not looking at something disconnected from the universe. You are looking at ancient cosmic material arranged into life. A temporary shape made from atoms that have traveled through deep time. Now think about how rare this may be. We know planets are common. We know stars are everywhere in the observable universe. But life is still a mystery. Earth is the only place where we know life exists. That does not mean life exists only here. It means we have only confirmed it here. And that difference matters. The universe may be filled with planets, but planets are not automatically living worlds. A planet needs the right conditions, the right chemistry, the right stability, and enough time. It may need protection from radiation. It may need liquid water or some other useful solvent. It may need an energy source. It may need an atmosphere that does not destroy its own chances. And even if simple life appears, complex life may be much harder. For most of Earth's history, life was microscopic. Complex animals appeared only after billions of years. Intelligence, technology, and astronomy came extremely late in the story. This makes the universe feel both hopeful and lonely. Hopeful because there are so many worlds. Lonely because we do not yet know how many of them ever become alive. This is why the question of alien life is so powerful. It is not just curiosity. It is a question about whether Earth is unusual or ordinary. If life is common, then the galaxy may be filled with hidden biospheres, quiet oceans under ice, microbial worlds, strange chemistries, and distant planets where life followed paths completely different from ours. If life is rare, then Earth becomes even more precious, a small living island in a vast, silent sea. And if intelligent life is rare, then the fact that we can look up and understand even part of the cosmos becomes almost impossible to take for granted. The silence of the universe is one of its greatest mysteries. The galaxy is old. There are billions of stars. Many planets are older than Earth. If advanced civilizations are common, where are they? This question is often called the Fermi paradox. Maybe life is rare. Maybe intelligent life is rare. Maybe interstellar travel is too difficult. Maybe signals are hard to detect. Maybe we are looking in the wrong way. Maybe the galaxy is full of life, but most of it is simple, quiet, and hidden. Or maybe advanced civilizations exist, but the distances between stars are so enormous that the silence is natural. A galaxy can be full of possibilities and still feel empty. Because space is not just large, it is separating. A radio signal weakens with distance. A spacecraft takes enormous time. A message between stars is delayed by years, centuries, or more. Even if someone is out there, the universe does not make conversation easy. This is one of the strangest things about reality. The universe may contain many worlds, but each world is isolated by distance. Every planet is its own small stage. Every civilization, if it exists, begins under one sky, around one star, with no guarantee that it will ever reach another. Now look at Earth again from that perspective. A small blue planet, thin atmosphere, liquid oceans, active geology, a protective magnetic field, a stable star, a large moon, a long history. Earth is not just a rock in space, it is a system. Everything here works together in ways that are easy to forget because we live inside it. The atmosphere protects us. The oceans regulate temperature. The magnetic field helps shield the planet from charged particles. The carbon cycle stabilizes climate over long periods. Life itself changes the atmosphere and surface. Earth is not simply habitable. It is alive with interactions. And the more we study other worlds, the more we understand how delicate habitability can be. Venus shows what happens when heat is trapped too strongly. Mars shows what happens when a planet loses much of its atmosphere and surface water. Europa and Enceladus show that oceans can hide beneath ice. Titan shows that chemistry can create familiar-looking landscapes with unfamiliar materials. The exoplanets we discover show that worlds can orbit in strange ways, around strange stars, under conditions completely unlike our own. All of this makes Earth feel less ordinary, not because it is magically separate from the universe, but because the universe creates many worlds, and only some may become gentle enough for life like us. Now think about time again. Earth will not remain as it is forever. The sun is stable now, but it is slowly changing. Over very long time scales, it becomes brighter. Far in the future, that will affect Earth's climate. Later still, the sun will leave its main stable phase and expand into a red giant. The solar system itself will be transformed. This future is extremely far away, but it reminds us of something important. Habitability has an expiration date. Even the most stable worlds do not remain perfect forever. A planet can be born too early. It can become habitable for a time. Then it can lose that habitability. Life exists inside windows, and our window is open now. That makes the present moment feel incredibly rare, not just because we are alive, but because we are alive during an age when the sun is stable, Earth is habitable, the universe is bright with stars, and the deep sky is still visible enough for us to study. The universe itself may also have a long-term future that becomes colder and darker. Stars will not form forever. New stars are born from gas, but over time, gas is used up, locked away, or heated in ways that make new star formation less common. The bright, star-forming universe slowly ages. Massive stars die quickly. Sun-like stars eventually become white dwarfs. Small red dwarfs may live for trillions of years, glowing faintly for far longer than the current age of the universe. But even they are not eternal. Eventually, in the deepest future, the universe may become dominated by remnants, white dwarfs cooling into darkness, neutron stars fading, black holes remaining as some of the last major objects. The bright age of stars is not forever. We live during the era when stars fill the universe with light. That may sound obvious, but it is not guaranteed for all time. The universe was once too young for stars. One day, it may be too old for many new ones. We live between those darknesses, a bright middle chapter, a time when galaxies still shine, planets still form, and observers can look outward into a sky full of information. This makes every image of space more meaningful. A galaxy is not just a galaxy. It is part of an era. A star is not just a point of light. It is a temporary furnace converting matter into energy. A planet is not just a world. It is a moment in the history of its star system. And life is not just something sitting on top of a planet. It is a brief and delicate pattern inside cosmic time. Now consider black holes again in the far future. Black holes seem permanent because they are so extreme, but even black holes may not last forever. According to our current understanding, black holes can slowly lose energy through a process called Hawking radiation. For stellar mass and supermassive black holes, this process is so incredibly slow that it means almost nothing on normal cosmic timescales. But in the deepest future, after stars have died and galaxies have faded, black holes may slowly evaporate. The timescales are so enormous that they almost stop feeling like time at all. Numbers with so many zeros that they become more like symbols than quantities. And after even black holes are gone, the universe may become extremely cold, thin, and quiet. This possible future is often connected to the idea of heat death, not a dramatic explosion, not fire, not a sudden end, but a state where usable energy becomes increasingly unavailable. Everything spreads out, differences fade, processes slow. The universe approaches a kind of maximum disorder where nothing much can happen anymore. A final quietness, a universe not destroyed in one moment, but exhausted over unimaginable time. This is a strange and haunting future, but it also makes the present more remarkable. Right now, the universe is not exhausted. It is active. Stars burn, galaxies collide, planets form, black holes grow, moons hide oceans, comets travel from distant regions, light crosses space, gravity shapes structure, and on Earth, life thinks about all of it. That may be one of the rarest facts in the universe. Not just that stars exist, not just that galaxies exist, but that the universe produced something capable of asking what stars and galaxies are. Consciousness is one of the deepest mysteries we know. We can study brains, biology, chemistry, and evolution, but the fact that matter can become aware of itself is still astonishing. The atoms in your body were once scattered across space. Now some of them are arranged in a way that can hear these words. Imagine galaxies, fear black holes, wonder about alien life, and feel awe at the size of existence. The universe is not just out there. It is also inside the mind, trying to understand it. That does not mean the universe has a purpose we can prove. It means that, at least here, the universe has become aware, and that alone is enough to make our place in it feel extraordinary. Now think about all the facts we have followed. Earth is moving even when it feels still. The sun is a star, ordinary in the galaxy, but essential to us. Light turns the sky into a time machine. The Milky Way is only one galaxy among countless others. Black holes bend space-time into regions of no return. Neutron stars compress matter beyond imagination. Planets can be hotter than metal, colder than night, locked to their stars, or hidden under ice. Moons can have oceans. Rogue planets can drift without suns. Dark matter shapes galaxies invisibly. Dark energy pushes the universe toward a strange future. Gravity sends waves through space-time. Stars create the elements of life. And the universe itself is aging. Each fact is powerful alone, but together they create a picture, a universe that is not simple, a universe where the visible is only part of the truth, a universe where beauty and danger are often the same thing, a universe that creates, destroys, recycles, expands, hides, and reveals. And somewhere inside it, Earth exists for a while, not forever, but as a rare place where the universe became warm enough, stable enough, and complex enough for life to look back. This should change the way we think about the sky. The night sky is not decoration. It is history. It is physics. It is time. It is the light of stars that may no longer exist. It is the glow of galaxies whose present we cannot see. It is the trace of processes that began before Earth was born. And when you look up, you are not seeing emptiness. You are seeing evidence. Evidence that reality is larger, older, stranger, and more creative than everyday life makes it seem. The universe does not need to be understood completely to be meaningful. In fact, part of its beauty is that it always remains larger than our explanations. Every discovery answers one question and opens another. We learn what stars are, and then we ask how they are born. We learn how planets form, and then we ask how often life begins. We detect dark matter, and then we ask what it is. We measure expansion, and then we ask what dark energy means. We see ancient galaxies, and then we ask what lies beyond the observable horizon. The universe keeps giving us facts that become doors, and behind each door is another mystery. That is why space never feels finished. There is always another scale, another object, another force, another hidden process, another future, another unknown. And maybe that is exactly why humans keep looking up. Not because we expect to solve everything, but because each discovery changes us. It makes the world feel bigger. It makes Earth feel more precious. It makes time feel deeper. It reminds us that daily problems, while real, happen inside a much larger story. A story that began before the sun. A story that will continue after the sun. A story written in light, gravity, matter, and time. Now, as this journey ends, return to one simple image. Earth floating in space. Blue, small, surrounded by darkness. No visible borders from far away. No labels. No divisions. Just one living planet in a universe of stars. Everything humans have ever known happened there. Every language, every memory, every ocean crossing, every city, every song, every question, every dream of the stars, all on that small world. And around it, the universe continues in every direction. Vast beyond imagination, filled with galaxies, filled with worlds, filled with forces we barely understand, filled with mysteries that may outlive every civilization. But the fact that we can wonder about it at all is extraordinary. We are not large compared to the universe. We are not powerful compared to stars. We are not ancient compared to galaxies. But we are aware, and awareness gives the universe a new kind of meaning. A star does not know it shines. A galaxy does not know it spins. A black hole does not know it bends light. But we can know. We can look at the light, study it, follow it backward through time, understand that it came from a place billions of years away, and feel something. Awe, fear, curiosity, peace. That may be the final and most important fact. The universe is not only strange because of what it contains, it is strange because it made something capable of being amazed by it. So the next time you look at the night sky, remember this. You are standing on a moving planet, orbiting an ordinary star, inside a galaxy of hundreds of billions of stars, in a universe filled with more galaxies than the mind can hold. The light above you is old. The atoms inside you are older. And the questions in your mind are part of the universe trying to understand itself. That is what makes space facts more than facts. They are reminders. Reminders that reality is deeper than it looks. That darkness is full of history. That silence is full of structure. That distance is full of time. And that even the smallest observer can still belong to the largest story. The universe is vast. It is cold. It is beautiful. It is dangerous. It is mysterious. And it is still unfolding. Somewhere, stars are being born. Somewhere, a black hole is feeding. Somewhere, a moon is hiding an ocean beneath its ice. Somewhere, light has just begun a journey that may not reach Earth for billions of years. And here, for a brief moment, we are able to listen, to learn, to wonder, to look into the dark and understand that it is not empty. It is everything, and we are part of it.